Hello, my name is Carlos Davila. I'm a computer engineering student with a minor in computer science. My part in this project is the benchmarking and profiling of the applications, as well as the design and implementation of the cluster.
Hi, my name is Jaewon Lee. I'm a senior studying computer engineering at FIU. My part on the Green Atom project is to implement FPGA to achieve hardware acceleration.
Hi, I'm Juan Medina. I'm a computer engineering student. My part of the Green Atom project is to implement hardware acceleration through the use of FPGAs.
Hi, my name is Jonathan Reyes and I'm a computer engineering student at FIU. My portion of the project is hardware acceleration using FPGAs.
I'm an Emmanuel San-Cristóbal. I'm a computer engineer with a minor in computer science. The parts of the project that I participated in is the benchmarking and profiling of software and the design and implementation of the cluster.
Our cluster is currently made up of 2 nodes, 4 cores. All nodes communicate through the Ethernet switch as seen here. This is our server node, the one that distributes jobs. The following is our client node, the one that receives and executes these jobs. And finally, our terminal to the server node, where we input jobs and manage the cluster. We begin with starting the daemons that will handle incoming MPI processes on each of the nodes. Here, we are specifying the 2 nodes we currently have up and running. The following command, npd trace, allows us to trace the NPD ring and check the nodes have successfully booted the daemon and are ready to receive and execute jobs. The ICPI benchmark, which calculates the number pi, allows us to test the speed of our system in a fast and efficient way. As seen on the screen, we are running 4 tests, each with a different amount of cores. As more cores are added, we can see that the calculation time decreases as expected. Using OProfile, we were able to detect which functions in our benchmark were taking up the highest percentage of CPU time. In the future, this will allow us to write code and integrate those functions in an FPGA as a form of hardware acceleration, thus taking stress off the CPU. For our project, we are making use of a Xilinx Virtex 5 FPGA board. We'll begin by talking about our methods of communication. We use a JTAG cable to upload code into the FPGA board. This cable is connected to our laptop via USB, as seen here. Next, we have a serial cable. This cable is used to send information from the FPGA board into our laptop. The cable is connected to a USB serial adapter and connects to the serial port on the FPGA board. To make use of the serial cable, we have to implement a UART peripheral in our FPGA board. To implement these peripherals, we are making use of a specific software called Xilinx Platform Studio. We are going to show a small demonstration of a peripheral that the team created that multiplies 2 numbers and displays the output. To implement this peripheral, we made use of the read and write FIFO. We have to modify the code of the read and write FIFO to redirect the inputs to write the outputs into our multiplier peripheral, and read the output from the multiplier peripheral and send the results through the bus. This would then be displayed in our hyperterminal via the serial cable. To make this test, we wrote a small C code that allowed us to test the peripheral by multiplying 4 different numbers and display the results in hex through the hyperterminal.